Okay, so today's lesson, completely brand new for BC. It's only a BC topic. A lot of what we do, like in this unit, is, and when we add these extra little BC things, it might show up as one single question on the AP test. Like on the whole, out of all, I think it's 51 questions long, it might be one question. Okay, I feel like we do a lot for this one question on the test. So what they're talking about here, okay? Let's see. Michaela, can you read us the essential question real quick? Perfect. Matthew, can you read us the Secant statement? Perfect. Okay. So this is it's arc length. It's basically what we're doing is we're figuring out how long this curve is. So we're finding the perimeter of the curve between a certain set of x values, which is something we have not talked about before. Okay. I'm not going to go into a lot of the nuts and bolts. I'm just going to show you how to do it. Okay. I'm not going to go into the theory behind it. I'm not sure how important this word is. A rectifiable curve is one that has a finite arc length. Okay. And then, as always, it has to be continuous and differentiable in the interval to be a smooth curve. Okay. If you are inclined to look at the proof of this and an explanation of the proof, there's a video right there. You may go ahead and watch. I'm not going to waste time going through it. Okay. Really what the key is making sure you understand the definition. Basically, those are the formulas. Okay. So it's the square root of 1 plus the derivative squared. So the integral of the square root of 1 plus the derivative squared. And I always forget if it's a plus or a minus. And I'm sure both answers would be there if it was multiple choice. So we're going to do one or two in the calculator. We're going to do one where we just set it up, probably. I am going to skip this example one because I'm not going to do all that. We're not going to do all that algebra. So let's just go to example 2. It's making these notes go really fast, isn't it? All right. So we have to find the arc length with respect to x. So find the arc length of the graph of y equals x cubed over 6 plus 1 over 2x on the interval from 1/2 to 2 as shown in the figure below. All right. So what I'm going to do first is I'm going to set up the formula. Okay. So I know that arc length, and I'm not sure did they give us a variable for it? S. Okay, so S equals a little s. Little s equals, I have to integrate. What are my bounds going to be? 1/2 to 2, and then I do square root of 1 plus the derivative squared dx. And that should not be under the radical sign. We can do the same thing if it's in terms of y. Okay, so that's what it is. We're going to, so I got to take the derivative of this nice little function here. So y prime equals 3x squared over 6. And then I got to take the derivative of that thing, which is like saying 1/2 x to the negative 1 power, right? So I take the derivative of 1/2 x to the negative 1. What do I get? Have we forgotten how to do derivatives? X to the what? You got to subtract 1 for derivatives. -2, good. So this is, if I simplified it, which I don't necessarily have to because I'm going to use a calculator to do the solving, I get x squared over 2 minus 1 over 2x squared. And literally, I'm going to plop that in here. X squared over 2 minus 1 over 2x squared. Okay. What I want you to do is I want you to get that typed into your calculator. I'm going to get my calculator turned on and do the same thing. Okay. So it'll take me a minute to get there. I closed it down apparently. So see if you can get a decimal point for that. If this is not on the, that's not what I wanted. If it's not on the calculator portion, it will only be a write but do not integrate type problem. but they would want to see you actually take that derivative on the inside by hand. Hopefully it's something nice. All right, I'm going to go here. I'm going to go here. So shift plus half 2 square root of 1 plus, I'm going to use some parentheses, x squared over 2 minus control divide 1 over 2x and dx. Oh, I missed a squared, didn't I? That's not what I got last year. Yes, there is. Thank you. That's where my typo is. There we go. Much better. Everybody good? Got the 2.062-ish somewhere in there. Oh boy. Okay. Let's take a look at the next one. The next one, we're just going to do the write but not integrate thing. Okay. I'm going to help you get started on it, and then I want you to see if you can write it. Okay. So in this case, do you see how it would be easier to write our equation in terms of y instead of in terms of x? I would have to cube root. I don't know. I guess it could be either way, but I think I would have to cube root, and I'd have to do a whatchamacallit, subtract 1, whereas I could just take the square root of both sides and rewrite that as y minus 1 to the 3/2 power equals x. Okay, so here's what I want to do. If that's what x equals, we're going to do this in terms, we just got to fly. Wasn't that great? All right, we're going to do this in terms of y. So when you do your bounds, make sure you use y bounds. Okay, they're in the picture. And then remember, you have to take the derivative of this thing. Okay, so I want you to see if you can get the formula filled in. It works the same for x or y as it does for x. Okay, so everybody try it. See if you can do it on your own. Don't integrate it, just get it set up. About 30 more seconds. Okay, what do we put as our bounds? 0 to 8. Okay, why 1 to 5 instead of 0 to 8? Yep, we're doing the y, so we want the y numbers if we're in terms of y. Does that make sense? Okay, So we're going to, so we've got to do the square root of what comes next under the square root. And then what am I going to do to the derivative? Square it. And technically this should read dy if I'm in terms of y. Okay. So I need to find the derivative of this thing. So I'm going to kind of do that off to the side. So x prime equals, I'm going to pull the 3/2 out in front. Y minus 1. What do I get as my new exponent? 1/2. And then technically it's a chain rule, right? But what do I get for my chain? It's just 1, so I don't really need to worry about writing down. So that's my derivative. I'm just going to plop it in here. Now, perfectly good answer for me if we're just writing but not integrating. In fact, please don't take it any further, okay? But I want you to be aware of something. So if I was to simplify that a little bit, okay? Remember that 2 has to get distributed over both. So it would make it 9/4 y minus 1 dy. Does that make sense? Because the 1/2 and the 2 would cancel, but you can't forget to also square the coefficient in front there. Okay? And then we're not going to worry about the integration piece because our calculator would do the work for us. So our calculator, though, in our case, we couldn't put in the y, so we usually trick it with just putting x in instead of y. It should get you the same value. Yeah. Most of them, or it would be right, but do not integrate. Okay, so it's most they because these are pretty awful to try to integrate, aren't they? Although we are going to do the next one by hand because it's not so bad and it reviews some trig we haven't done in a while. So we're gonna do that one by hand. But yeah, it would most likely be on a calculator part. Okay, or like write but do not integrate. All right, write tiny. Okay, I think you can squish it in if you write small enough. I wrote really big last year and I didn't get it all in, but it's got some interesting. This has some interesting stuff in it, so I want to make sure that we see it before we just start. Whatchamacallit? Before we let it go out of our grasp here. Okay, so we're going to start setting this up. We know we've got to do arc length of y equals the natural log of cosine x. We've got to go from 0 to pi over 4. So they gave us the picture there. It looks like a parabola, doesn't it? So that little darkened arc there, that's what we're doing. So to start arc length, I know it's s equals, what are my bounds going to be? 0 to pi over 4. Good. All right, and then what's the next part of my formula look like? Square root 1 plus, and we got to take the derivative and square it dx. Okay, I'm going to take the derivative out in the left-hand column just because that's where I have some space, and I want to be able to try to squish all of my work in there. All right, so I know that y equals natural log of the cosine of x. So I've got a chain rule going on, don't I? So what is the derivative of the natural log of anything? 1 over x. In this case, it would be 1 over cosine x. And then I got to take the derivative of cosine. What's the derivative of cosine? Negative sine x. Interesting. So I've got, and I notice I did my chain rule without my u thing, right? We've been doing that for a while. So that's the same thing as saying negative sine x over cosine x. That seems like a trig identity we did a while ago. What's that trig identity? What's sine over cosine equal to? Yeah, so it's negative tangent of x. That's why I'm showing you this one, just because we've got some interesting trig identities. I ran into one of last year's calculus BC students. He's taken Calc 1 at UCR, and he's been through AB and BC, but in a pandemic, and his mom passed away in the process, so it was a rough year. But he, he said that the way they use quadratics over there is incredible. So the more I can show you little tiny things that we haven't done in a while, the better. All right. As again, it's not the calculus that kills you, it's the algebra that's embedded in there. All right, so negative tangent x squared, wouldn't that just be tangent squared? So isn't this the same as saying 1 plus tangent squared x dx? Well, 1 plus tangent squared looks kind of familiar too, doesn't it? Isn't that a trig identity? Which one is that? Oh, it's secant squared. So I've got 0 to pi over 4 of the square root of secant squared x dx. I'm going to zoom in so it's a little bit bigger for you. Okay. Can't I take the square root of secant squared? Yeah, what's that? Isn't it just secant? Derivative of secant squared is just secant, isn't it? Just like derivative of x squared is just x. All right. Now we come to an integral that we know exists. We've seen it. We tried to memorize it probably at some point, but my guess is it's not in there right now. Okay. So right now, Google, okay, what is the integral of secant x? Because it's going to do you better if you look it up than if I tell you what it is. Okay. All right, what do we find? Natural log, good. Absolute value of what? Good. And then we don't need the plus c because we've got the 0 to pi over 4. Okay. All right. It's not so bad. So we were able to look it up. So now I'm at the point where I'm going to plug in the pi over 4 and the 0. And again, I went all the way by hand on this problem because now we get to review some unit circle, which is always good to go back and revisit. Okay. It's also got a natural log in the problem 2 different times. Isn't that so cool? And trig. So exciting. All right, natural log absolute value of secant of pi over 4 plus tangent of pi over 4. And then I'm going to subtract natural log absolute value. And remember, when we have zeros with trig, we have to check to make sure that we don't just cancel. So always, always, always use the zeros with trig, even when they're on the bottom. All right, I'm going to get out my unit circle. My favorite thing, right? It looks like I need pi over 4. Isn't pi over 4 right here? What's the coordinates at pi over 4? Do you remember? It's one that we should know really, really well. Yeah, square root of 2 over 2, square root of 2 over 2. Okay, and then we also look like we need the coordinates at 0, which would just be AB out 1, up 0. All right, what is secant the reciprocal of? Cosine. So I'm going to take the cosine value and I'm going to flip it, right? So natural log absolute value of 2 over square root of 2. Doesn't matter that there's a radical in the denominator. Tangent, remember, is sine over cosine. So when I do square root of 2 over 2 divided by square root of 2 over 2, what am I going to get? 1. Good. And then let's see. Secant of 0. So 0, we're going to flip the cosine value. What do we get? What's the reciprocal of 1? 1. So this is going to be 1. And then tangent is sine divided by cosine. So what's 0 divided by 1? Good. So this back piece, isn't it just going to be the natural log of 1? What's the natural log of 1? It's 0, so that goes away. So it's just this front piece, the natural log absolute value of 2 square root of 2 plus, and I would not simplify it more than that since we're doing by hand. So we've seen one by hand, had a lot of nice trig and algebra and logarithms in it. It's great. Okay. I want to show you, once you kind of got that, I want to show you one thing in Delta Math really quick, because that's where I made the assignment out of. I think Delta Math is saying use your calculator on things. And I believe Delta Math is only doing the X direction, not the Y direction. So the Y was kind of a nice to know more than a need to know. But let me get in there and find, because I just want to point out, you can totally do the assignment with the knowledge you have. It's just, I want to point out one thing to you. Calculus. So I gave you arc length level 1 and level 2 is the assignment on this one. We see this again when we do the Unit 9 parametrics. All right, so here's what one of the problems looks like. And they have done this. They've done a question on the test, on the AP test, where they ask you to find the perimeter. And like one of them is usually like a horizontal line, and one of them is like it's like a line with a slope, but you could figure out the length of it. And then one part of it's a curve. So really all you have to do is add up all the lengths of the sides to find perimeter, right? So instead of you just finding arc length once on a problem like this, you'd have to find this arc length here that's blue and then add it to the arc length that's red. Does that make sense? So you're just going to have to do 2 arc lengths and add them together. I didn't show you how to do one of those, but you have enough in your knowledge to do that. Okay. So it's just adding up 2 arc lengths versus just doing one by itself. So that was the second level. The first level is just 1 arc length. Okay. Yeah, you could find the bounds using points of intersection because those don't look like they're nice, right? But yeah, absolutely use the bounds finding your points of intersection. Okay. But you all know how to do that. I shouldn't have to teach that again, right? All right. Congratulations. That was the last notes of the year, 2021. So we'll have more notes in 2022, but we're done with 2021. Okay.